So here's a practice problem for finding tangents to polars, and the question is to find the horizontal and vertical tangents of r equals cosine theta. So here we have a graph of r equals cosine theta, pretty much just a circle, and here's the equation for tangents to polars, and you can go to the previous video if you don't know how to derive this or if you forget. So let's go ahead and start off with the horizontal tangent. Or should I say tangents, because it'll be a couple. But so the horizontal tangent occurs here where the tangent is horizontal, which means that the slope of this tangent line, or dy dx, is going to equal to 0. So when does dy dx equal 0? That's going to happen when the numerator is equal to 0. So we can completely forget about the denominator for the horizontal tangent, and that's going to be true for I'd say about all horizontal tangent problems. You're just going to look at the numerator, and you want that to equal 0. So let's go ahead and do that. And we know what r is equal to, and we can find dr d theta. That's going to be negative sine theta. And now we pretty much just need to plug it in and solve for theta. So plugging in dr d theta here, we get negative sine theta times sine theta, which gives us a negative sine squared theta, plus r is equal to cosine theta. Cosine theta times cosine theta is equal to cosine squared theta. That equals 0. So from this, we know that cosine squared theta is equal to sine squared theta. And what this pretty much means is that we're looking for the points theta, where cosine and sine of theta are equal. And we're ignoring the sine because we have the squared. So just thinking back to trig, when does cosine equal sine? And that occurs at theta equals pi over 4. And usually you might have a lot of different theta values that'll give you a horizontal tangent. But when that happens, you probably want to find them up until from 0 to pi over to 2 pi. So you're looking at a whole revolution. So theta equals pi over 4. When else does this occur? Well, it'll also occur at 3 pi over 4, 5 pi over 4, and 7 pi over 4. So that's going to be the angle of the point at which the horizontal tangent, there is a horizontal tangent. So let's go back to our graph of r equals cosine theta. Well, pi over 4, that's this point over here, and as you see, there's a horizontal tangent. 3 pi over 4 would bring you back here, 5 pi over 4 would bring you back up here, and 7 pi over 4 would that'll be down there. So now let's look at the vertical tangents. And I guess the real question that we're solving for is to find theta, where find the angle at which there's a horizontal and vertical tangent. So just to clarify that. So for the vertical tangent, unlike the horizontal tangent, that's these points right here, where the tangent is vertical. Well, that happens when our slope is undefined. I guess you could call it an infinite slope, but it's undefined. And when will this be undefined? Well, it'll be undefined when the denominator is going to equal to 0. So we really don't care about the numerator. We just want the denominator to equal 0. So pretty much all we're going to do is we're just going to solve for when the denominator of our tangent equation of dy dx when is that going to equal 0? Once again, we know r equals cosine theta, dr d theta equals negative sine theta. And from here, once again, we're just going to be plugging in values. So if we plug in dr d theta, we get negative sine theta cosine theta. And again, I guess we get another negative sine theta cosine theta. And if we move one of those overs, pretty much we get negative sine theta cosine theta is equal to sine theta cosine theta. And once again, if we think about this, well, these are the same terms with different signs. You could divide by cosine, you could divide by sine, but pretty much we want sine theta to equal negative sine theta equals sine theta, and cosine theta, negative cosine theta equal cosine theta, and that'll occur at the zeros of sine theta and cosine theta. So we want sine theta equal to 0 and cosine theta equal to 0. So that'll occur at theta equals, well, for cosine theta we have 0 and pi, and for sine theta we have pi over 2, and what'll that be? 3 pi over 2. And so these two solutions are the angles of the points where the tangents are horizontal and vertical.